You know what I mean? There's a difference between having your paths accelerated towards something and actually having you accelerated towards something. You know what I mean? But we can all see here, if these are a million miles apart and that's a million miles apart, that just because these paths intersect in an accelerated rate, it doesn't mean that either one of these balls are accelerated. Neither one of them are accelerated. Yes, they are accelerating towards each other, yes. But neither one has been accelerated to do that. They just had their paths, just by coincidence, just by happenstance, their paths cross each other a million miles away from each other. You know what I mean? It don't change anything. This ball is still going to be floating in a ship, and this is still going to be floating in a ship. Both of them are still going to be going 50 miles an hour. Both are still going to be going in a straight line. They're both inertial. Nothing. Everyone would agree with me. But yet, this is the same exact thing. Here's the ball and here's Earth. Or here's the ball and here's the black hole. It's the same exact thing. And you might say, oh, look, these are all curved. No, this is curved space-time. And so, obviously, straight lines are curved. Here, these straight lines are in flat space-time. So, obviously, these straight lines are straight. But both of them are straight lines. Both of them are straight geodesics, okay? They're both straight lines. Just one's a geodesic straight line and one's flat space-time. These are the same exact things. If you could just snap your fingers and put the ball above the Earth or the spaceship or whatever, right? Above the black hole or whatever the heck it is, right? And you gave it the same momentum, the same direction, the same speed, so that you could basically say that the planet or black hole and the ball are standing still, right? Relative to each other. Because no matter where, if they're going this way, it's the same, same velocity, same direction. It's just like they're standing still. So let's say that they're standing still. The ship or the man, the ball, whatever, and the planet and the black hole. Well, if they're moving through space relative to each other at the same way, so that you can say they're standing still, then their clocks are ticking at the same rate, right? Right? So that means their clocks are ticking the same rate. That means they're going through time at a constant velocity, and they're both doing the same constant velocity, right? Their clocks are ticking the same way. So let's say that they're standing still, and these are these lines right here are time. They're just the ball is going through time, right, or the spaceman, and the Earth or the black hole is going through time, right? They're going through them they're constant velocity. They're going through time, man. They're not like speeding up going through time or something. No, they're going at the same constant velocity, straight path. These two are the same exact thingies. Remember how we said these are a million miles away? So, and this was a million miles away from both of them. So obviously this never changed to be accelerated. The ball still floats. It's inertial. Same here. But this is the same exact example. This is the same example. This guy in this video, okay, is basically saying, he's giving us this example, right here, with this man and this thingy right here. They're both inertial. They're both going through time, just like here. He's saying that even though they're a million miles apart, once you know that this blue line exists, and you know that the paths are accelerating, that this changes now, and all of a sudden his velocity changes, his direction, his speed, everything just changes. He becomes accelerated. Bull. But that's basically what he's saying, right? Isn't that what he is saying? He is saying, because this is basically what you have in this scenario, right? The guy is standing here, the black hole's here, same scenario here. There's a guy and whatever, same example here, except it's in flat space-time. Same example. And what happens? The space shrinks between these two people. The space-time shrinks in between these two people. And the space-time shrinks between these two people. Right? But you can see, if he's floating above the black hole, right, then that means they're moving through time. They have the same velocity, both the black hole and the man, right? Which means they're moving through time. They're moving through space, basically standing still relative to each other, right? So you can draw two geodesics, right? they're just traveling. Their clocks have to be ticking at the same rate if they're traveling through space the same rate, right? So they're traveling through these geodesics at the same speed, constant speed through time. Not the only thing that happens is that in here the space-time is shrinking. It's getting accelerated down to Earth. You can see it. Here's the here's the acceleration part of it. You know what I mean? You can see. But this is no different from this, and this is no different from this. You have two straight lines where people were traveling on them straight lines, or people, objects, whatever, black holes, planets. They're moving at the same rate through time, right? So they're both constant velocity through time. Straight lines. There's no difference. They're all the same exact thing. And if you were if these were a million miles apart, and this intersection was a million miles from them, and they were both moving at 50 miles per hour, we would say that they were everything was floating. We'd be like, oh, they're all in inertial frames. We wouldn't say just because their paths accelerate, like over here it says, because they themselves are not being accelerated. We would understand that in our brains. Why can't you understand it here, which is the same exact thing? Even the graph looked exactly the same. And then why can't you, if you can understand both of these, why can't you understand this then? That this guy is inertial, right? Over here, right? He's inertial because he is standing still relative to space-time. This guy, why is this guy, he's closer to the black hole. Why is he time dilated more than this guy? Because he's accelerating more. He has to accelerate more. This guy only has to accelerate a little bit because he's so far away from the black hole. That's where you get why you have time dilation less the more you move away, because you have to accelerate less the more you have to move. The more you move away, and why? Why do you have to do that? Because space-time is being accelerated down. Okay, and you have to overcome that acceleration. All right, it's that simple. It's not. I'm not doing rocket science here. I'm basically saying if you're on a hill like this little truck here. The only way that you can be standing still relative to the ground and everyone else in the universe is you have to be accelerating to overcome the gravity. That's all I'm saying here. That's all I'm saying here. Okay? And that's where the time dilation comes in from. Not from... This guy is not time dilated. He's in free fall. He is moving at a constant speed at a straight line. Okay? This guy is deviating. He is not moving in a... If he was falling, yes, he'd be falling on a straight line geodesic, but he's accelerating. That means he's moving off of his geodesic. He's moving away from his straight line. He's accelerating. He's getting time dilated. Okay? And this is the truth, all right? And the truth is, you'll never see this thing where the guy is frozen there, okay? Because to be frozen like we're, even at 99% speed of light, you're only like 7 times dilated, man. So that means 1 second for 7 seconds. You wouldn't be frozen there for millions of years, okay? You'd have to be going like 99.9999999% of the, at least 99.99% to dilate it by 70, times. So that 1 year would be 70 years. You know what I mean? Yeah, okay. But think about it. Sooner or later, your thrusters ain't gonna. You only have so much gas, so much thrusting. You know what I mean? Sooner or later, you're going to lose your thrusters, and you're going to become inertial. And at that point, you will just fall directly into the black hole. There will be no time dilation because you will move into an inertial frame once you lose your thrusters, right? And as soon as you do that, you're just going to follow the geodesic. You're just going to follow the geodesic down into the black hole. Okay, there will be no time dilation for you. Okay, and yeah, we're taking out stuff like you're obviously going to be fried by all the radiation and stuff like that and the heat. We're taking that away, and we're taking away the fact that you're going to be red shifted the more you're going down. Because it all depends on how fast your ship is going. You know what I mean? Are you really going to get your ship up to 99% of the speed of light? I doubt it. And even if you do, so what? What is that, like 7 times the dilation? Big whoop. No ship is going to have that much energy to do that, man. It's going to fall. It's going to try to overcome it, and then it's going to lose all its thruster power. It's going to turn inertial. It's going to be the same as this guy. It's going to fall right in there. Now, because of this, you know, the acceleration of space-time downward, you know what I mean, being faster than the speed of light, yeah, he's going to, you know, you're not going to see him. Because the light's going to be so redshifted, you're going to get redshift and redshift and redshift to the point where you can't even be seen, man. You know what I mean? But yeah, at that point, there's no time dilation once you lose your thrusters, right? And you turn into this. No time dilation anymore. You just, boom, you turn into, your clocks go back to normal. There's no time dilation, blah, 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 blah. So let's go in and see this woke podcaster, right? He says that, you know, he's going to, we'll go over the thing, we'll see what he says and whatever. But basically, my whole point is, he's basically saying that this red ball going 50 miles per hour in the middle of a void with no planets, all of a sudden turns into an accelerated frame of reference if a million miles away we find out that there's a blue spaceship with a blue ball in it going 50 miles an hour on this path, and then we find out the two paths are going to cross over each other in like a million miles away. Then all of a sudden we're like, oh no, you know what? This red ball is an accelerated frame of reference. That's basically what this guy is saying, this woke guy, this woke thingy. He's saying that, hey, yeah, you know, even though they're moving at constant, even though this guy he's moving at constant velocity, yeah, okay. Yeah, he's moving in a straight line. Okay, yeah, well, yeah, everything in his frame of reference is floating, including him. But you know what? I'm just going to use my emotions, and I'm going to override all those facts that you just mentioned, and I'm going to say this guy's in an accelerated frame of reference. That's what I'm going to do, because that's what woke people do. They put their emotions over facts. That's what they do, okay? If I have time to put this on to the end of the videos, yeah. Why do these woke podcasters use the word non-inertial? I'm going to go over this, why they keep using this nonsensical word, non-inertial. Why can't they just say accelerated frame of reference? If you had a car lot, and let's say all the cars in the whole world, they only made two colors, red and blue, okay? And you go into the car shop, and the one car shop saying, well, the red cars have this, and the red cars have that, and the blue cars have this, and the blue cars have that. And then you go across the street to the guy, right? He's telling you, he's like, yeah, the red cars have this, the red cars have that. And these non-red cars, yeah, these non-red cars, they have this, and the non-red cars have that, and we'd all be like, why are you calling them non-red cars, you idiot? Why wouldn't you just call them blue cars? What's wrong with you? That'd be the first thing in my mind is, why are you calling it non-red or whatever I just said? Why wouldn't you just call it blue? What is wrong with you? And this happens with these woke podcasters, and no one ever says, why don't they want me to know the word acceleration? Why do they want it? Because they want to lie about what acceleration is. Yeah, they want to use this non-inertial. There's no such thing as non-inertial frame of reference. It's accelerated frame of reference and inertial. There's no non-inertial, just like there's no non-blue cars or non-red cars. A non-red car is just a blue car. You call it a blue car, you moron.